Okay, great. So we have basically, I want to congratulate you, we have finished quadratics. It was 2 entire chapters. It was chapter 9 and chapter 10. And you guys did it. You did a great job. You know it better than most ninth graders that graduate from a Algebra 1 class. I'm quite impressed. So now we're moving into another segment, and it's going to be talking about radicals, okay? So first of all, let's talk about when you say radical, because like this would be a radical, right? This is a radical sign, right? Now, but what do you guys know it as? Square root. All right, so why would we have 2 different names for the same thing? Anybody know? Because we're trying to be difficult. Exactly. No, exactly. Not quite. So, but basically square root is only one type of a radical. Okay?
Oh, because it's like cube roots.
Yes, exactly. See, when you have a square root has a hidden 2 right here, which means like I need a number multiplied times itself twice, 2 times, right? Times itself, right? To get 16. So 4 times 4, there's 2 4s, and 2 4s, right? So that's the square root of 4 times 4, which is 4, right? It's the square root. It means I have to have 2 of the same numbers inside for it to come outside the radical sign. Does that make sense? You with me, Sakara? You with me? Okay. You can also have a cubed root. So, yeah, this is square roots, but this is now cubed roots. But this sign itself is a radical sign, okay? All right? And so, cubed root of 8, right? I have to have one number times itself 3 times, right? So 1 times 1 times 1 is 1. 2 times 2 is 4 times 2 is 8. So the cubed root of 3 is 2 times 2 times 2. You guys agree with me?
Yes.
All right, and there's 3 of them, so they can come outside, and it just gives me a 2. So that's my answer, right? So that's how it all works. I could have the 4th root, or the 5th root, or the 10th root, or the millionth root, if I really wanted to be stupid and spend my time doing that, right? Right? But you can, right? It works. Where's my curtains? Okay, so a radical sign, so we call these radicals because we're not always talking about square roots. We might be talking about cube roots or 4th roots or whatever, okay? But in general right now we're going to be looking at square roots, okay? And graphing square roots and understanding how those graphs work. So what I'm going to do is I'm going to draw a graph over here to the far right. And we're going to use this for a while. And I've got that's fine. And then okay. So all right. So we're going to start with the first one. The first one, if you notice, since this is our first time using the textbook, okay, chapter 11.1 for this textbook, okay? Chapter 11.1, it says graph square root functions, and it says in that blue box, the key constant says the parent function for a square root functions is y is equal to the square root of x. That's the parent function. So this is the parent function. Just like standard parabola guy, y equals x squared is the parent function for all of the parabolas, right? For all of the quadratics. This is the parent function, or I don't know, we could call him the standard root guy, right? Standard root guy. Okay? So he's real important. If you know him, you can do everything. All you have to know is him. And then you have to know what these things do to the graph. And then remember how with standard parabola guy, we found the vertex? And once we found the vertex, we could plot it at that point, pretending like that point was 0, 0, right? Over 1, up 1. Over 2, up 4. Over 3, up 9. Right? Remember that? So as long as we found the vertex, we knew where the point was. That's where we plotted standard parabola guy. And it was a piece of cake to plot the graph. Okay, the same thing is true with these. Okay? Now, first of all, we're going to talk about this one in a little more detail. We're going to actually do a t-chart and figure out what this would be. So y is equal to the square root of x. We're going to do a t-chart here. Here's my x and here's my y. Now, with a t-chart, you choose your x's. For straight lines, I always told you do 0, 1, and 2, right? It's really easy. But for parabolas, that didn't work because you might not be where it just didn't work, right? You didn't know where your vertex. If you don't know where your vertex is, you could be doing it. You know, your vertex could be over here, and you could be doing all these points over here. So you'd never see the turnaround. You see what I'm saying? So you'd need at least 5 points for a parabola. But for one of these, let's choose our easiest points for x. If I did 0, that would work. What's the square root of 0? 0. So if x were 0, the square root of 0 is 0. So y would be 0. That is easy. What's my next number I could easily find the square root of? Before that? 1. So if x were 1, what would y be? What's the square root of 1? 1. Oh, that's easy. Now, I could do 2, but then I'd have to get out my calculator, and I wouldn't be able to graph it very well, because it's going to be somewhere in the middle of something, right? It's not going to be, so what's my next easy point? 4. So I'm going to choose 4, and what's the square root of 4? 2. All right, we'll do one more just so that we can graph it. What's the next one I would choose? 9. Square root of 9 is 3, right? Okay, so do you understand? You're choosing the easiest numbers to use, right, to create this. Okay, so now let's plot it. So 0, 0, boom. All right, 1, 1, boom, boom, right there. 4, 2, 1, 2, 3, 4, up 2, right there. Okay, 9, 3, this is 9, and there's 3, so right about there. Okay, so this is our graph. It's a sideways half of a parabola. Okay? It's a sideways half of a parabola. Now, with a parabola that we've been working with in the past, we could go either side, right?
And
Right?
there's an arrow in it, right?
I'm sorry, what?
Arrow.
And there is an arrow, you're right. Thank you. Right? With a parabola, we could go either side of the vertex, so to speak, right? But with this, I can't. I mean, you could say that the square root of 1 is plus or minus 1. Then technically I could. But not if it's going to be a function. Remember our conversation. We had a conversation our last class on Friday. And we talked about functions. And what was one of the main rules about a function? There's one y for every x. For every x, there is only one y. So if I did this, and I went over to x is 4, how many y's would there be? There would be 2.
Yeah.
Well, then it wouldn't be a function, right? I mean, this is still a legal shape, but it wouldn't be a function. So if I'm talking about functions, and that's what we're talking about in this section, this is called graph square root functions, right? See the word functions right there? So because it says functions, I can't have this bottom one, because then I would have 2 y's for every x. So it's not possible. So I have to keep them positive, okay? Is that clear so far? All right. So that's pretty easy, right? That's the parent guy. That's the parent square root. That's the standard root guy, okay? Now, what happens if we do y equals ax squared? All right, y equals y equals a square root of x. Sorry. All right, so here's my graph again. Now, I'm going to choose the same things because I want something that comes out of the square root sign, right? So 0, 1, 4, 9. Okay, so let's now make the a, let's make the a 2. Okay? So y is equal to 2 square root of x. Sorry about that, I should have written that first. Y is equal to, so my a is now 2. Okay, so if x is 0, square root of 0 is 0, so y is 2 times 0 is 0, right? Square root of 1 is 1, 2 times 1 is 2. Square root of 4 is 2, 2 times 2 is 4. Square root of 9 is 3, 2 times 3 is 6. Right? Pretty easy, right? All right, so all this does is it takes the standard root guy and it multiplies the y answer by the a, by that number in front of the square root sign. That's just like y equals 2x squared. Remember that? Over 1 up 1 times 2. Remember that? Over 2 up 2, over 2 up 4 times 2. Right? This is now going to be this. Over, well, 0, 0. And then over 1 up 1 times, over 1 up 1 times 2, which is 2. Over,
Does it look different?
over 4 up 2 times 2, which is 4. Over 9 up 3 times 2, which is 6, right? You're just multiplying that number times the y's to get a new y. And all it's going to do is it's going to make it taller, right? Remember? Right? Unless it was a fraction, because a fraction is going to make it shallower, shorter. But if it's a whole number, so we'll graph it. There's 0, 0, 1, whoops, 1, 2. And then 4, 4, 4, 4, right around there. And then 9, 6, 9, 6-ish. Right? So it's going to be this graph. So that's y is equal to 2 square root of x. And this is y is equal to the square root of x. Okay, you guys with me? It's pretty straightforward, right? It's not that hard. It's just that that a number is going to make it steeper if a is above 1, like 2 or 3 or 4. Now if a were 1/4, if it was a fraction, it would think about it, it'd be 1/4 of these numbers, so it'd be down here somewhere. You know what I'm saying? If it's a fraction, it's going to be smaller, shorter.
What if it's 7 billion?
It would be really tall. Right? Okay. Can I erase some things? I'm going to change colors now. But I'm gonna still leave that. Actually, I guess I'll just erase that. All right. So we now know this. We know this, right? Everybody clear on this? Vista 5 so far? Are you with me? Right? Okay. It's really easy. Look at this. Y is equal to the square root of x plus k. So all that's going to do
So you just add
is
whatever k is.
whatever k is, you're going to add that to these numbers, right? So we'll try one. Y is equal to, I can tell right now this isn't going to work. Let me try a different number, color. Y is equal to, where am I?
The square root of x.
Oh yeah,
K.
square root of x plus 5. Okay?
Shouldn't the square root of x be in parentheses? So it's not like x plus 5 and the square root of x?
No, because there's no danger of that because
Oh, because that doesn't
that
accept
line
it.
doesn't cover the 5, right? The plus 5. So, all right, so all I'm going to be doing is adding 5 to each of these y's. Does that make sense? Right? Because that is just the square root of x. That's the standard root guy. Y is equal to the square root of x. And I'm just going to be adding 5 to both of these. Add 5, add 5, add 5, add 5. So really my y is 5, 6, 7, 8. Right? Does that make sense? All right, so let's try that. Let's graph it. So when x is 0, my y is 5. 1, 2, 3, 4, 5. This is where I now begin. All this k is doing is moving the graph up 5. Does that make sense? Remember, like, that is sort of like your y equals x squared, y is equal to ax squared plus bx plus c. That's like your c. Remember the c always moves it up or down? If it's minus, down, and up, positive, up. Your c is what moves it up and down, right? Right? The same thing is true with these. It's just taking this graph, y equals x squared, because that's the graph we're talking about, and it's just moving it up to here. So once I've moved it up to there, I could either use these 1, 6, 4, 7, 9, 8, or I could just say, I could use standard standard root guy, right? And I could say, okay, 0, 0, right there, 1, 1, right? You with me? 4, 2, right there, and 9, where am I? 9, 6, right?
It's the same shape as it's the same points as a parabola.
It's going to be exactly the same as this one, just moved up 5. Does that make sense? Everything has been moved up 5. You get that? That's all the k is doing. It's moving it all up 5, the whole graph up 5. I don't have a lot of time. I'm just wondering if I should stop and finish. I think I should finish this tomorrow. Is that okay? Because I don't want to, because the next one's just slightly more confusing. Not very, but slightly, right? And but that's the main thing. So you now know y equals x squared. You have, y is ax squared. It's just going to make it a steeper slope or a shallower slope. And then you know y is equal to x squared, which is standard root guy, plus a number. Or what about y equals x squared minus 7? What would I do for that? Y is equal to x squared minus 7,
Then
really
you just
fast.
take away 7 from all.
Yeah, y is equal to square root of x, not x squared, square root of x minus 7.
Then you
I go down 7, 1, 2, 3, 4, 5, 6, 7, put a dot. And then I use standard root guy. 0, 0, 1, 1, 1, 4, 2, and then 9, 3, right? Boom.
What
Right?
about x, y equals -2 square root of x?
Y is equal to -2 square root of x. That's a good question. So all you're going to do is you're going to be multiplying your y's by -2, right? So now it'd be 0, 0, 1, -2, 4, -4, 9, -6.
Okay.
So it's going to be, it'll be down here like this, right?
Yeah.
Something like that, right? Make sense?
Yeah.
All right. So good, awesome. So homework tonight. Homework tonight. We have done examples 1, 2, and 3. Okay. So what you're going to do is you're going to use graph paper. If you don't have graph paper, you can get some there. But take graph paper home with you because you're going to have to draw your graphs out. Feel free to use a straight edge. You know what I mean? Keep them fairly neat looking. In high school, they really expect that, so it's probably a good idea to get in that habit. You're going to do, okay, you have your planner out? Everybody get out your planner so I can tell you what you're going to do. Okay, you are going to do page 713 through 714. Numbers,
Can you repeat that?
Wait,
page 713 through 714.
And then he's going to tell us the numbers?
And then the numbers I want you to do are let's see, 3, 4, 5.
Can you write this on the board?
Yeah.
Yeah. Page 713,
Wait, and then you're reading us off the problems that you want us to do now.
714. Do numbers 3, 4, 5. 9. 10. And then also, 15. Just one to make you think. And then let's do 17 through 20. And that's it.
Wait, so you do from 3, 4, 5, 9, 10.
15, and then 17, 18, 19, 20. Okay? Again, some of those are odd numbers and the answer's in the back. I want you to check your answers, okay? And those that aren't, you will just have to hope you're doing them right, right? Good job, guys. I'm sorry the book is so heavy.
Yes, sure you are, Gary.
That's